Hello everyone. My name is Jamit Wasawa, and today uh, we'll be discussing about machine learning using Python, recommender systems. Before this, we covered a case study on the forecasting, and today this will be covering the case study on the recommender systems, which is module 10, part 1, and this is session 19. In today's session, we'll be discussing about recommender systems, what are recommender systems, how they are used by the platforms, and we'll be discussing within the recommender systems the association rules. So recommender systems are used by, you can notice the use of recommender systems in very large platforms like Amazon, Netflix, Spotify, YouTube, and so on. So recommender systems basic use or need is that to cater a very personalized user experience to the user. So it adjusts the amount of products or amount of content according to the use that the user has interacted with in the past. So some of the examples for recommender systems in whenever you shop through Amazon, you can see this segment called customers who bought this item also bought, and then the list of items that are similar to something that the user has selected or bought. So similar segments are also existing in different OTTs or different social media platforms and stuff. So Netflix has shows and movies that you may want to watch. Then Spotify and YouTube Music, and they recommend similar songs from similar genre or similar artist or the same artist. Then it comes coming to Pinterest. It shows us an image which is shows the images that are that it has, which are similar to the one that the user has been watching. Instagram and Facebook, and they also have a segment which shows if a user has been following certain kind of people or personalities, then it will recommend certain personalities which are common among the people who follows certain celebrities or certain people. So recommender systems are very popular for recommending products such as movies, music, news, books, articles, groceries, and act as a backbone for cross-selling across industries. So that was the introduction regarding the recommender systems. Now we'll be discussing about association rules. In a very basic sense, if I ask you to understand the association rules, is basically to have an association of one item with another. So if, let's say, we are shopping for breakfast, then we have bought bread, then we are very likely to buy butter, or being more specific, peanut butter, or we buy cereals, or we buy jams, or anything that is more associated with bread or eggs or something like that. So association rule finds combination of items that frequently occur together in orders of or baskets. So And the items that frequently occur together are called item sets. So the item sets helps to discover relationships between items that buy people and that people buy together. Sorry, people buy together and use that as a basis for creating strategies like combining products as a combination or offer or place products next to each other in a retail shelves to attract customers' attention. Now, these kind of strategies helps a business generate more money by selling more items as customers get involved into looking through some of the products that they might have missed or for some reason. And while checking out for the bill, they are likely to check out some of the items. And if they find it attractive or they find the need of it, then they might purchase the item. So, association rule mining, which is what we are discussing. One of the application of it is market basket analysis, which is also termed as MBA. So MBA is a technique used mostly by retailers to find associations between items purchased by customers. So let's take an example. If a basket contains egg, orange juice, sugar, bread, yogurt, the basket 2 contains egg, orange juice, cereal, bread, yogurt. The third basket contains milk, orange juice, and bread. And the fourth one contains cereal, yogurt, bread, orange juice. So the new basket or the association rules uh, application consists of what might be another product that might be added if orange juice is already added into the basket. So recommender system aims to predict items a customer might purchase based on past behavior or past buying behavior, and then to predict what a customer might purchase. For our example, orange juice, and we can use an association rule mining to identify items frequently bought alongside orange juice in previous baskets. So association rule, it considers all the possible combinations in the previous baskets and computes the various measures which are support confidence and left to identify strong associations. Now, the thing is that there are many items that are sold by the seller or by the shopkeeper, and to find an association, let's say a person is only bought 3 items, but the shopkeeper sells a total of 117 to 120 items. So the association to buy 3 items and the actual sold items are very large. So to find the combinations for 3 items being bought out of 117 to 120 items, it is computationally very heavy, and we need high computational power to process these kind of combinations. So the main goal of association rules is to uncover the patterns. If people buy A, they are likely to buy B. So this is useful for things like market basket analysis, where stores can arrange products based on what customers commonly buy together. So as I said, that association rules, rule mining evaluates all the combinations in the past basket, calculating 3 factors. starting with support. So support is how often the rule appears in the data set. Then confidence is the likelihood that the part of the rule happens if the if part is true, and lift shows how much more likely the then part happens with the if part compared to chance. So one solution to this problem is to eliminate items that possibly cannot be part of any item data sets. So for that, we use a priori algorithms, which are a method in association rule mining to efficiently find frequent items. So it does this by eliminating infrequent items early and building on a smaller frequent sets. So the first, which is eliminating infrequent parts, items or combinations that do not meet a minimum frequency threshold are removed, which is also called a support. And then the building on smaller frequent sets. Only combinations that include frequent subsets are considered, reducing the total combinations to check. So by filtering out low frequency items, a priori reduces the computational load and helps identify meaningful item associations in large data sets. So the rules generated are represented as, let's say we started with a bunch of breakfast items and stuff. So uh, if yogurts, then we buy oranges, which means that or yogurts pointed towards orange juice, which means that customers who purchased yogurts also purchased orange juice. So here, yogurt is called antecedent and orange juice is called consequent. And both of these can have multiple items. So you can see that in the example, yogurt and milk are bought together. So orange juice and bread are can be consequent. So now we'll be discussing formula-wise what are support, confidence, and left. So the support for oranges and yogurt, if we take just an example, so 2/4 of the time, if it occurs, then we have 50% of it appearing together in the 2 out of 4 baskets. So uh, going with the similar kind of analogy for two items X and Y. So N are the, so N will be the total number of baskets, and XY represents the number of baskets in which X and Y appear together, and NX represents the number of baskets in which X appears, and Y represents the number of baskets in which Y appears. So the support is given by NX Y divided by total number of items, which is represented by N. Total number of baskets, sorry. So to filter out a lot of to filter out the stronger associations, we can have the minimum support of 0.01, which means that 1% of the baskets have these items. So if the minimum support is 0.01, and so then association of items X and Y will be considered if and only if both X and Y have minimum support of 0.01. So the a priori algorithm computes support for each item independently and eliminates items with support less than minimum support, and can be calculated using the formula that we just discussed, which is nxy divided by total number of baskets represented by n. Next are confidence and lift. So confidence measures the proportion of the transaction that contains X, which also contains Y, where where X is antecedent and Y is consequent. So so confidence X given Y, or probability of Y given X, is given by nxy by nx, and then the lift, which shows much more likely the then part happens if with the if part compared to the chance. So the lift is equals to support xy divided by support of x and support of y, which is nothing but nxy divided by nx into xy. Sorry, ny. So if the lift is equals to 1, which means that items are independent and has no association. If lift is smaller, lift value is smaller than 1, items may be substitutes. And if lift is greater than 1, buying one item increases the likelihood of buying another item. So we'll be using to understand these association rule mining techniques and understand this concept, we'll be using a data set called groceries.csv. Now groceries.csv is available on GitHub on CSU Eastbase GitHub, which I'll be linking on the reference part at the end of the session. So this groceries.csv, we will have to work with it in order to load it first, rather than what we have done it since the past session, in the past sessions, and directly reading it. So first we'll be reading the file and saving all the files, all the lines of the data set in all transactions, which is a list that we have defined at the very first. So what this piece of code, you can see that the explanation, it reads the CSV, reads all the lines from the file, then removes the separation, splits it using the comma, and stores the item of each line in the list that we have created, which is all transactions or all TXNs. So to display the first few items of the transactions, you can see the first transactions, how they are. The list, it's a list within a list. So from 0 to 4. Now, we need to encode these transactions for because it needs to be in a specific format. So for these formats, we'll be using ML extend, which provides a method to generate association rules from a list of transactions. So the transactions and items need to be converted into a tabular or a matrix format. So in an M cross N, where M represents the total number of transactions and N represents all the unique items available across all transactions, or the number of items that are sold by the seller. So the items available in each transaction will be represented in one hot encoded format. So for which one meaning that the transaction exists and 0 meaning it doesn't. So we'll be using the necessary libraries, or we'll be using the transaction encoder in order to transform them into one hot encoded platforms, and then using the a priori and association rules from ML extend. So one hot encoding the using the transaction encoder, and then transferring all and saving it into one hot transactions. So to watch the first values from 5 to 10 and the columns from 10 to 20, you can see which are the ones. And if you look at it, there is a field called butter, or the column butter, which in which the fifth transaction has the purchase of butter. Then in the seventh transaction, we have bottled beer as a true. So you can see that the values of these transactions, not transactions, but if we create the one hot encoded transactions, the values are very sparse, which means that we can have a total of one transaction or one purchase, and the rest of the values will be uh, zero or not bought. If we check at the shape of the DF that we have created, we have 9,835 uh, total transactions, and we have 171 items that are sold by the seller. Now we can use we can calculate the number of item sets that can be possible using the combinations formula. You can see the combinations formula n factorial divided by n minus r factorial into r factorial. So which comes down to 14,535 item sets. Now it's a very large number and also computationally very heavy. So we want to limit those generated rules by the help of a priori algorithms. So these a priori algorithms will be taking the parameters. First will be the data frame that which will be in one hot encoded format. Then the minimum support value, which we in the past, for example, we used it for 0.01 or 1%, and then the column names. So we use the frequent item sets to store those values and use the a priori algorithm. We used our data frame minimum support of 0.02, not 0.01, 0.02. The 0.01 value was only taken as an example before, but here we'll be taking as 0.02, and the use column name equals to true. Now using this and having the sample of the first 10 data sets and saving those in a random state of 90, you can see that the first 10, how the samples look, the 10 samples look like. If we see that, then on the 119th, you can see that it's 0.056 for a whole milk and yogurt. So 5.6% of the baskets, the whole milk and yogurt appear together. And for this, these kind of things, so these item sets can be passed to association rules for generating rules and corresponding matrix. So for association rules, which takes these parameters, which is the data frame, the matrix. The matrix can be confidence and lift. By default, it is confidence and the minimum threshold for evaluation metric to decide whether a candidate rule is of interest. So you can see that for rules in the association rules, we used frequent item sets, which is the data frame that we created. For metric, we used a left, and for minimum threshold, it's 1. And when we print the 5 samples out of it, you can see the a detailed snapshot of those 5 values and the columns that antecedents, consequence, then support and consequence, uh, sorry, antecedents and consequence, support value, confidence value, left, leverage, conviction, Zhang matrix, etc. So right now we'll be only working with support and confidence and left. So if we sort the values from higher to lower uh, with the respect to confidence, then this is the list that we get. So so from this um, uh, there's 10 rule top 10 rules of association. We can say that probability of a customer buying whole milk with any other vegetables is 0.51. And now these kind of things can be used to generate strategies which for items that can be bought together or store uh, to keep it on the store shelves and stuff. Now there are some of the pros and cons for the association rules. The advantages are that the transaction data which is used for generating rules is always available and mostly clean. The rules generated are simple and can be interpreted also. But on the negative side, they do not take into preference or rating given by the customers into account, which can be very important. So let's say for an example, a customer bought 2 items and one of which the customer did not like. So such kind of things can give us a good feedback on customers' reaction to the purchase. So such kind of things are taken into consideration when we use things like collaborative filtering and stuff, which is the topic of our next session, along with matrix factorization. So to look at today's session as well as summarizing it, just a quick thing. We used a ML extend just in case if you have not have it installed, you can install it like this, and this is how it will appear while the installation is taking place. So after the installation is done, remember we used all transactions and saved all the transactions happening from the groceries.csv. Printed the first few items from that file. Then we used a transaction encoder to one hot encode all the items. We have one hot encoded, and then these were the this was the dimension of the data frame. We had 171 items that was sold by the shopkeeper. Then we used a priori algorithm which takes a data frame, minimum support value, and the column use. Displaying the 10 samples from that frequent items. And you can see over here, this was the example that we considered, that 0.56 or 5.6% of the time, the whole milk and yogurt were bought together. Now, using the association rules and left as a metric, we used it, and you can see this is the detail that we get. If we sort it in a descending manner for the confidence, whole milk and yogurt combined with other vegetables were the one that appeared the most, which and things like this can be used in order to make strategies on which items to keep on store shelves and stuff. So we introduced ourselves with recommender systems, got familiar with association rules, worked with a data set, and used a transaction encoder in order to use it, because it demanded a particular format for which we used ML extend library, and then generated the top 10 rules of association. So this is the reference for the dataset that was used, which is glossaries.csv. And in the next session, we'll be covering collaborative filtering and matrix factorization. So thank you. This was the session on recommender systems, and we discussed about association rules here. And next, in the next session, we'll be covering continuing and covering the other topics. So thanks a lot for listening. Thank you.